My pleasure to introduce the next speaker, Manuel Ray. Yes, here he is. He's Semiconductor 3D Experience Senior Director at, how do you pronounce this? Dassault? Dassault. I knew some alphabets are going to disappear. This is what I thought. It does look like that. So Manuel joined in 1986 and has held various positions of responsibility in the development of DS solutions dedicated to the high-tech industry. He spent 3 years in the USA as DS project manager within IBM hardware divisions. And since 2005, Manuel was in charge of the Smarter, Faster, Light 3D experience, which addresses the end-to-end development of a mechatronics system. Let's please hear it for this speaker and for a meaningful session. Thank you.
Good morning, and it's a great pleasure for me to be here with you today. Actually, I have just a comment to make to the last session. I really enjoyed it, and I just have to say that I have a 17-year-old daughter, so she is in high school, and I am spending some time this year today with her in order to decide what she is going to do next year. She wants to take biomedical engineering, and for that she will need to do electrical engineering. And I wish she could have been here with me, listen to the panel. Thank you very much. So I would like to take you to a 30-minute journey on what we call silicon thinking. Silicon thinking is an experience, an industry solution experience that we built and that we brought to the semiconductor community. But before we go into silicon thinking, let's just have a look of what is Dassault System, who we are, and what we do for a living. Okay, so Dassault System, first of all, was originated in Dassault Aviation. You know Dassault Aviation. They are about to cooperate with the Indian government about the acquisition of the Rafale military jets. So we were born in Dassault Aviation, but now we are a single company. We are the software branch of the Dassault family in France. And this makes me going to the point on the right side of the slide, which is we are a family-owned company. Dassault family has the main stakeholder of our capital, and we are long-term driven. We are able to have a dream, to make this dream happen, and to have the time to build the dream for our customers. So we proud ourselves to be a scientific company. Of course, we need to do business, we need to make a living, but we try to combine the science and the technology, and we try to use science and technology to help our customers building better products in order to make the world more sustainable. We are a little bit less than 14,000 people all over the world, and we have a global R&D with 54 labs. At least we have 2 major labs in India. Okay, so we are present not only in the sales side, but also in the R&D side. And we have a little bit less than 200,000 customers and 10,000 partners. Among those partners, I would like to identify just one of them, Chipware Technologies. So Chipware is our partner here in India and here in Bangalore to help us and to help our customers in the semiconductor industry using and taking value of our solutions. High-tech industry, what does it mean for Dassault System? First of all, it's the 4th largest industry for us in terms of revenue. We are serving 12 industries, and it's the 4th one. okay? It's the second largest in terms of growth of our revenue. And we have a little bit less than 32,000 high-tech customers all over the world. And only 1,700 of them are large or medium companies. So that means that we have a lot of very, very small high-tech companies that are using our solutions in order to create tomorrow's products. The biggest customer we have in high-tech has a little bit less than 40,000 users working with our solutions. The smallest one is something in the range of 10 to 15 users. And we can accommodate this variety of companies. High-tech means for us three OEM type of segments. Consumer electronics, security control and instrumentation, and computing and communication equipment. And means also three types of companies supplying those OEMs with products. So you have contract manufacturing services and engineering manufacturing services. You have technology suppliers where most of the electronic system design and manufacturing is done. So that's basically one of the topics of the IESA Vision Summit. And the last one that I'm going to focus in my speech today is semiconductor. In semiconductor, what we identify 4 different subsegments, from IP providers to integrated design manufacturers, fabless and fab-light companies, and finally, foundries and fabs. So this said, now I would like just to come back and to share with you our vision, our understanding of what is happening in the high-tech industry. And I would like to start by saying that I am very, very, very happy. What I have heard yesterday here makes me very proud of being here with you, makes me also being proud of knowing that India is playing and is also willing to play a major role in the transformation that is happening in that industry. So, to start, we have been talking yesterday and today about innovation, about IoT. Today, high-tech is transforming the world. We are going to see profound changes in all kinds of things that we use to make our daily journey. You have in that slide some examples of what is happening. We talked yesterday about driverless, autonomous, connected cars. This is happening. And the question yesterday was, how long does it take to get a driverless car running into the road? Well, actually, it already started. You have in the Tesla S, you have an autopilot mode that makes you able to drop the steering wheel and let the car drive by itself. Of course, it's just on a highway today. But I'm sure that within the next 5 years, we will see some kind of this starting to take over. But the revolution is happening in many other places. Healthcare, just by taking the right clothes on a baby, you can monitor the heart rate, the breathing. You can automatically get alert if there is anything wrong while he is sleeping, And I could go with smart homes, the way we are going to handle our living will change dramatically. And I can talk also about drones. I can talk also about the virtual reality and what virtual reality will bring us. But I would like just to finish that slide by the startups. And I would like also to take this and to correlate to the previous session by saying that one way for women to elevate in that industry is also by thinking about what can change our daily life. And I think in that sense, women are better positioned than men. Why? Because usually they are the ones that runs the home business. You know, it's like home business is like a small enterprise. They need to do parallel processing, they need to take care of everything, and they are the ones that are better placed to understand what are the single devices or the single ideas that can change our lives. So this industry is transforming, and this is going, there is a huge opportunity for people to innovate. We see new things happening everywhere. New everything means new types of customers. The way my children consume the information is very, very different from the way I consume it. And it's also very, very different from the way my grandchildren will consume it. You have new business models. I'll just take one example here, Uber. Uber is causing a trauma in the world, not only in the US, not only in France, I mean in all countries, because it changed our relationship to the taxi industry. Okay, and this new business model makes us believe that the technology today provides the means to change to happen. And finally, new engineering, because of course at the bottom of this transformation, tech engineering is what makes all of this possible. And engineering is also changing. There is new types of engineering, systems engineering, modularity, system on chip. We talked yesterday about ASOCs, not SOC anymore, ASOCs. We talk about 3D printing. These are also new things. And what this means is that we need to provide our customers and we need to provide their consumers with holistic experience for them to accommodate this new way of living. I'm going to now take a very, very small example to explain a little bit why I think this transformation is so disruptive. I'll take the example of the Nest thermostat. Basically, I remember the first time I bought a thermostat for my house, it was a complex device. I had to program it. And I have a daily program, a weekly program, but you know, sometimes when you were going on a holiday for a week, you need to change the settings, okay? So at least, of course, I have an engineering degree, so, well, I could cope with that. But look, here, this device is as simple as press, set, period. And the first day, the device will learn. The second day, you change the settings, it will learn a little bit more. The third day, and so on. And the device will learn by itself your habits, which temperature you want, at which time of the day, at which time of the year, and it automatically adjusts itself to accommodate your needs. Now, this device is fairly complex, okay? But the good thing is that we have taken out the complexity from the end user. Okay? And if you look a little bit of this device, of course there is hardware, of course there is software, of course there is content and services to run and to make this experience being possible. But what it does is that we have taken this behind the end user. And we have focused on defining exactly what is the value for the end user, what it cares about, and what it needs to do in order to have the device operate properly. And everything else has been taken on the outside. So, of course, we need engineering, we need mechanical and electricals, we need electronics, we need software, we need simulation, we need all of that in order to build and to imagine that device. But we need to think about the end user. We need to think about the experience. And by thinking about this, this is where we are going to create value. Let me just have one slide about IT. Of course, we are in the capital of IT in India, and I would say also in the world. I mean, okay? So let me just spend 2 minutes on IT. You know, you have heard about PDM. Okay, PDM is about document management. CAD management is about visualization. Okay, and after we've gone through PLM, so we took the management of data and the management of files, and we have added requirements management, we have added project management, we have added issue management. So we have enlarged the scope of the business process we could do around the documents we were using in order to produce the products. Okay? Now, I think it's time now to elevate this to the next level. Okay? The next level, we need to focus on the experience, on the user experience. Because, in fact, you cannot create good products, valuable products, if you do not know what is the experience you are going to provide to the end user. Okay? And in order to do so, you need much more than managing files. You need much more than managing projects and programs. You need data, not files, to be available to everybody in the ecosystem. Not only the engineers, okay, but also the people on the fabs, the people in procurement, okay? And you need also to simulate. You need also to be able to simulate the experience before actually you produce it. You need to make sure that you are going to produce is going to provide the value. And there is only one way to do that, is the simulation. And it's the real life, the behavioral simulation of the experience you are thinking about. So we need to go from modeling products to create experiences. And in order to do this, it is as simple as doing two things. Move from managing files to be data-driven. And move from static information, static engineering, to model-based engineering. Now, let's go and focus about semiconductor, because this is what we are here today, and I would like to address the semiconductor business reality. Only 45% of launches meets their original launch date. We have a time to market issue. 60% of the projects needs at least one respin. And one respin today, if you look at the technology, is several thousand US dollars to several millions. And only 60% or a little less of semiconductor designs makes it into production. So over 40% exceeds the budget, and when you are not in time, you can lose from a quarter to roughly half of the potential revenues. This is the reality. These data are coming from IBS, Calypso, other sources. And when you look at how this reality is, actually, it's all about deadlines. It's all about data, wrong or incorrect data going to tape out. And it's all about wrong resources, wrong product definition. So what this industry needs is the ability to reclaim the cycles that are spent on fixing preventable issues. Okay. It's also ensure data integrity. Make sure that when you send files, they come with the right label, so that you are not going to end up with a lot of 1 million pieces that are functionally correct, but that they have the wrong label on them. So you need to dispose of these pieces. And finally, you need to ensure that you have an efficient and consistent collaboration in the design process in order to make sure that you are working on the right product with the right team and make the project go through. So at Dassault System, we have taken our 3D experience platform and combine the power of our 12 different brands and create industry solution experience to serve 12 industries. Among these industries, high-tech is the industry I am working in. And I have had the privilege to take our valuable brands, applications, and to create silicon thinking. So silicon thinking is an industry solution. It is industry specific. It is dedicated to semiconductor companies, okay? It provides semiconductor companies with the ability to manage their end-to-end semiconductor design process. Yesterday, one of the keynote speakers talked about make in India or do in India. And he qualified that with 3 or 4 major steps. One is innovation. The second is the create or the design. The third is the make, manufacture, and the fourth is support. Actually, silicon thinking is able to address the 3 first steps. Innovation happens in project and portfolio management. It happens also in managing the requirements and understanding what it is that you want to create, what it is that you want to provide as an experience to your customer or to your consumer. Okay? So innovation can be addressed. The second is design or create. And here you have IP management, you have collaborative design, and you have verification and validation that can help create and design the right devices for the right purpose. And of course, on top of that, you have issue and defect and change management. Okay? So that's the second step. And finally, the make or manufacture are addressed by the semiconductor manufacturing configuration. So this is where you start planning front-end manufacturing. And you start defining where you are going to produce all the different sales items that you can take out of a single die or a single wafer. So then after you move to the packaging, you need to manage the packaging and you need to manage the reliability of the package through thermal, through stress, through moisture. So you need to make sure that the final product that you are going to provide to your customer will be reliable and will meet the reliability requirements. And finally, 9, we are going to focus about yield optimization. So here we cover 9 different processes of semiconductor product. Okay, and this makes our customer thinking not any longer about the design complexity and the switch from one node to the other, but also they allow them to design platforms and to create from those platforms different variants to address specific markets, to address specific needs, and to make their business more profitable. Because they can split the cost of the design of one platform into several product lines, into several product variants, in order to achieve a better profitability. So, I have a couple of more slides, but I'm going to skip them. Okay, they will be in my final presentation. You will see we have more details on the value, more details about the differentiators we do provide. I would just like to spend 30 seconds on this one. This is an industry-proven solution. If you take the top 20 semi companies in the world, 18 of them are already users of silicon thinking. You see some examples and you see some details on how they are using silicon thinking to manage and run their semiconductor business. And I would definitely be available to talk to you on a one-to-one basis if you need to have more details about that. I would like to leave a few minutes for questions, if there are any.
Arthur. So I run that IoT for. The software is very good. I have had some friends give me a demo and all that, but it's also fairly expensive for startups to get hold of. Is there a bureau service? Is there a way of mentoring where people who are just starting a product and want to be able to simulate certain characteristics, crash tests, etc., and get this done?
Yeah. So as I said in the beginning of my presentation, so we have customers that are going from a few seats to several 10,000s of seats. So we have different solutions to accommodate very simple, very newer startups as well as the big companies. So the answer to your question is yes. We have the ability to start very specifically on a specific application, on a specific process, on a specific business challenge to address. And after we can grow, you can implement more of the solution as the time goes. So yes, we can accommodate different business challenges, starting from very, very small and specific to the larger and company or corporate-wide ones. Another question?
So, my experience with Dassault, I remember having attended some conference in Mumbai where they were talking about this product. It was more about, as you said, the documentation management, and also maybe some on the CAD side. That's been your legacy, has been on the CAD side.
Yes.
Right?
Yes.
So bringing in the silicon part into it is really a step towards IoT. So how are you? How do you see the entire spectrum of tools? How are you merging this, and can you kind of elaborate a little bit more that as a person who's going to do an IoT solution, where do they start with this?
Yeah. So when we think about IoT, we think about several levels of products or experience. First of all, you have IoT starts with a sensor or with a semiconductor. Okay, and I had a conversation with a journalist sooner this morning. Semiconductor is the heart of IoT, because without devices, without sensors, IoT cannot happen. Okay, so we are, if you look at the players in the IT industry, in the software industry that are providing solutions for the engineering business, we are the one that can claim that we can accommodate the whole IoT chain. From the design and making of the device through the electronic system, then this electronic system get built into a product, whether it is a home product, whether it is a car, whether it is an airplane, or whether it is a medical device, okay? And so you are able to simulate the behavior of the chip. This chip goes into a PCB. You are able to simulate how this PCB is going to behave. And then you go to the product, and you are able to simulate how this product is going to behave. And this product will be part of a system. So we used to say that we help our customers defining the system, and after defining how this system will behave with another systems. So we are very well placed to embrace and to help our customers embrace this IoT revolution. If you look at our customer base, and I'll take one example of the automotive electronics, okay? So automotive electronics today, we have semiconductor companies that are designing chips. Those chips are used by tier 1 suppliers to create ECUs. And those ECUs are then going to be assembled in cars, okay? And if you look at the customers, we have customers in semiconductor that are discussing and collaborating with tier 1 suppliers. And they are using exactly the same platform. They are using, of course, the semiconductor is use silicon thinking experience. Electronic system design companies will use another experience called smarter, faster, lighter. And the automotive OEMs will use another experience called smart, safe, and connected car. But the foundation and the bottom line is that all those three experiences are relying on the same platform, our 3D experience platform. So that means that there is a continuum of data, continuum of flow, continuum of collaboration throughout the different actors. And I took the example of an automotive, but you can take the example of any other product or service, and you have the same continuum. And so this is why also it is important today, if you want to be very, very productive, not to manage files. Why? Simple reason is that when you are looking for an information, okay, if the information you are looking for, if the data you are looking for is buried in an Excel spreadsheet or in a CAD file or in another type of document, it will not be visible to all the actors. If you manage data instead of managing files, you can make data available on purpose for the right people, for the right purpose, and for the right need. Okay? Thank you very much.
Thank you so much. I mean, these are one of, some of those industry sessions where we hear the industry directly speak and from hands-on experience. So when you spoke about semiconductor complexities and how to turn them into market profitabilities, we know that you are speaking from experience, having been there. Guru Ganeshan, may I request you please to step up on stage to hand over a memento to Manuel Ray as a token of gratitude. Thank you so much for coming over to the summit, adding so much value as well, and making it meaningful for us. Thank you.